Okay, so this is the first lesson in Unit 3, and in this lesson we are going to be identifying pairs of lines and angles. So when three lines are intersecting at different points, there's different pairs of angles that have special properties. So we're going to talk about some relationships in three-dimensional space. So we have kind of looks like a cube here kind of, and it's got a bunch of different points and lines. So we're going to think of each segment in the figure as part of a line. And we're going to name the lines or planes that fit each of these descriptions. So we're looking at part A. It says we're finding a line or lines parallel to CD and containing point A. So I'm going to trace CD just so we have a reference. Okay. And then I'm going to mark point A. So from kind of knowing some of the vocabulary behind parallel means two lines that don't intersect that are part of the same plane. So we need to find a line that is part of the same plane as CD and will never intersect. So the line that follows that is going to be line AB. Okay. So AB is parallel to CD because it will never intersect and it is part of the same plane. Now AH, if we look at that would never intersect, but it's not part of the same plane as CD. So that comes into our next example. Skew lines. Skew lines are lines that do not intersect but are not part of the same plane. So in this case, a line that is skew and contains point A, that would be line AH. So skew lines are lines that do not intersect and are not part of the same plane. So AH would be an example of a skew line. Another example of a skew line, if you look closely, is the line AG, okay? Because AG, if we look at it, it's going along this side. It's never going to intersect CD, and it isn't part of the same plane. So that's another thing to keep in mind. So parallel and skew both mean not intersecting, but parallel lines have to be part of the same plane. Skew lines are not part of the same plane. And then moving ahead, perpendicular. We should remember perpendicular means they intersect at a right angle. So a line that is perpendicular and goes through CD, that would be AD. And we can assume that because of that right angle symbol. And the interesting thing here is there's only one line that's perpendicular to CD that also goes through point A. It's just AD. And then finally, we're going to talk about parallel planes. So a parallel plane to EFG that contains point A. So if we look at that, EFG is, if we look at this as kind of like a room, I guess, we think of EFG as the floor. Okay, I'm going to trace it. So a plane that's parallel to EFG and containing point A is, I would think of it as like the ceiling. Okay, so I could name that point or that plane ABC. And you can name that plane a lot of different things. ABC, ADC, any combination of 3 points from that plane. So a plane that's parallel, if I'm thinking in terms of the floor, the ceiling is parallel to the floor. So next, you're applying some of that vocabulary in this guided practice. So I'm going to give you a few seconds to pause the video and work through it, and then you come back and you check in with me to make sure that you're kind of understanding the vocab and some of the terms that are new and some terms that we've learned before but are nice to review. So I'm going to have you pause the video here and then check your answers to the guided practice with me in a few minutes or seconds, however long it takes you to work through these. Okay, so in number 1, it says we're looking for a line parallel to MN that contains point J. So I kind of traced MN and I traced point J because I'm looking for a line that crosses through J and is part of the same plane as MN. So here's JL. I would say JL looks parallel. It's kind of like a triangle where, think about this as almost like a roof. So those would be parallel because they're part of the same plane and they never intersect. And then skew has a similar definition of parallel. Skew means never intersecting, but not part of the same plane. So JK would be an example of a line that never intersects MN, but isn't part of the same plane. And then for 3, it's a little tough to tell, but perpendicular, there's no sign for perpendicular, but it appears. That's why I kind of boxed that there. It appears to fit that description. So JN appears to hit that perpendicularly, and it goes through J. So the main thing is it has to go through J and fit the description. Okay? And then finally, the plane that contains point J and appears to be parallel. Now this plane, JKL, I know it looks like a triangle, but almost think of this as like another room. This is one wall, and this plane would be the other wall. So those planes would never intersect, and that plane contains point J. So it's important to read the description. Okay, so next we're going to move on to a few postulates. Now memorizing the names of these postulates is not what I care about. What I care about is that you remember the definition of them and how to apply it. So the parallel postulate says, if there is a line L, let's just say line L, and there's a point not on that line L, there's only one line through that point that is also parallel. So for every line and a point not on that line, we can only draw one parallel line through that point. There's only one, okay? There's no other lines that are parallel and go through that point. Works the same way with perpendicular lines. If I have a line and I have a point not on that line, there is only one perpendicular I can draw through that point. So that one says, if there is a line and a point not on the line, there's exactly one line through the point that is also perpendicular to that given line. There are no other perpendicular lines that go through point P. So we're going to identify parallel and perpendicular lines, which we've kind of already gotten the definitions of these down in Unit 1. So we're going to use that diagram to answer these questions. We're going to name a pair of parallel lines. And part of this is just you being able to read markings. So if we look at these arrows, there's an arrow here, and there's a little arrow here. So that means that these two lines are parallel. So I'm going to say line AB, and I'm going to label it with the arrows. AB is parallel, so it's just two vertical lines. It's parallel to CD. So that marking means parallel, okay? The two vertical lines next to each other. That says AB is parallel to CD. And then perpendicular, if we look at this right angle symbol, that's going to be this line right here and this line right here. So the way I would represent that is AB, line AB, is perpendicular to line AC. Those are perpendicular to each other. They cross at a right angle, okay? So I'm going to erase some of this mess I made here, and I'm going to answer this last question. Is AB parallel to BC? So I'm going to highlight AB again, and then I'm going to highlight BC. And I think we should be able to tell that those do not cross at a right angle. And I would say no. And you could just say because it looks like that, but that's not a good enough explanation. I would say a good enough explanation is there is no marking indicating a right angle. Let's see if I can spell. Indicating a right angle. There's no marking indicating a right angle between those two lines. So we cannot assume, okay? It obviously doesn't look like a right angle, but again, if I don't mark it, I can't necessarily assume, okay? And then this last part, we're going to have a graphic organizer to help us keep all these straight because this bleeds into our next lesson. But we're going to talk about angles formed by transversals. So basically, anytime we have two lines and they're being intersected by the same line, that line is called a transversal. So we've got in this first example, top left with angles 2 and 6. We've got a line, we've got a line. This line intersecting both of them is the transversal. It's called the transversal. So there's different relationships that we're going to have to know, and I'll explain this further in the next lesson. But the first relationship is corresponding angles. So if I have two lines cut by a transversal, two angles are corresponding angles if they have corresponding positions. So angles 2 and 6 are above the lines and to the right of the transversal, making them in corresponding positions, making them corresponding angles. So angles in corresponding positions on the same side of the transversal, and either both above or both below the lines that they are part of. Okay. And then next, alternate interior angles. Two angles are alternate interior angles if they are in between the two lines and they're on opposite sides of the transversal. So alternating sides of the transversal and on the interior of the lines, inside the lines. So that helps us remember alternate sides of the transversal on the interior of the lines. Alternate exterior angles. Opposite kind of alternate interior angles. They're on alternate sides of the transversal, but they are on the exterior of the lines. So these are two angles being alternate exterior angles. They're called alternate exterior angles if they lie outside the two lines and they're on alternate sides or opposite sides of the transversal. And then the last relationship, consecutive interior angles. Two angles are consecutive interior angles if they lie between the two lines on the interior of the lines and they're on, and I made my first typo here. I will fix this in the notes I give you. They're not on opposite sides of the transversal. They're on the same side of. They're on the same side of the transversal, okay? That'll be reflected in your notes. I'm going to fix that before I give the notes to you. So they're on the same side of the transversal. So we also call those same side interior angles. So if you hear same side or you hear consecutive interior angles, those mean the same thing. They're on the same side of the transversal on the interior of the lines. So for the guided practice, what I'd like you to do is use those definitions above to help you identify all of the pairs of each given angle type. So you're going to have more than one pair for each of these angle types. So I'd like you to take a minute, use the examples above to help you determine which angles are corresponding to each other. So pairs of two, as many as you can name. So I'm going to give you a second to pause the video and then check your answers with me in a minute or so. Okay, so to explain these angle pairs, I'm going to go through each pair and explain why they fit the description. So corresponding angles first. There's 4 pairs of corresponding angles. The first pair I picked out was 1 and 5. 1 and 5 are both on the same side of that transversal above it and on the left of each of their lines. So that's corresponding positions. Angles 2 and 6, they're both to the right of their lines and above the transversal, so that's corresponding. And then you should be able to kind of see that 3 and 7, they're both below and to the left of their lines. 4 and 8, they're both below the transversal and to the right of their lines. So those are corresponding positions. Same side of the transversal, same side of their respective line, okay? Alternate interior. 2, if I'm going 2 is on the interior, the alternate interior angle of 2 would be 7. They're both on the inside and they're alternate interior angles. 2 and 4 would not be alternate interior angles. 2 and 4 are a linear pair. So then the other set of alternate interior would have to be 4 and 5. And we're going to talk about the special properties that these have in the next lesson. So this is just naming them, going from the diagram and naming them. Alternate exterior, angle 1 and angle 8 are on the exterior of the lines. They're on alternate sides of the transversal. So 1 and 8 are alternate exterior angles. And then the next pair, 3 and 6. 3 and 6 are both on the exterior. They're on alternate sides of the transversal. And then finally, consecutive interior or same side interior might be easier to remember. 2 and 5. They're on the same side of the transversal and they're on the interior of the lines. Consecutive interior. 4 and 7. Same side of the transversal on the interior of the lines. So a lot of this is being able to name them right now, okay? The reason I want you to be able to name them is because being able to name them is going to connect this to a property, and that property has some applications with specific types of lines. So I'm going to have you guys move on to some form of practice in this part of naming these types of angles. So don't be worried about memorizing them right now. Just focus on being able to pick them out, examples of them, from this diagram. Again, I will give you a graphic organizer that's going to help keep these things straight, okay? So you can move on to the next part of the lesson.